Welcome. I'm Speed at the bottom of the helix. We're doing another September NMRAx update, monthly update, and it feels almost like a lifetime we've not been here. Thank you for an awesome convention here in DFW to distract us a little bit from all this fun. Well, our first presenter has been a train and model railroad enthusiast since the late 1950s. He enjoys building his own structures, turnouts, and other complex track work for himself, and listen to this, for others as well. He is currently building an HO scale layout of the main Central Railroad's Mountain Division circa 1950. Two levels with the top ready to haul freight. Please welcome Bill Huebner.
Good evening. Thank you, Speed. What a wonderful introduction. Um, yeah, and I help others, but I have to get hot food in return. I work for food, so pretty simple. Um, but again, good evening, everybody. My name is Bill Huebner, and I'm going to be talking about a different way of controlling our turnouts and our model railroad layouts. I've been doing this for decades and have tried pretty much everything, all the different products that are out there. And today I'm going to talk about what's called a Bullfrog, and that's a manufacturer's name, not my name. And this is what they look like. Um, there's a company called Fast Tracks, and you can see the website there. It's run by a gentleman named Tim Waris. I bought many of their products over the years. Great company, wonderful customer service. Again, I'm not getting paid for this. I'm just a customer. I just work here. Um, but anyway, this is one of their offerings, and it's a simple lever switch machine, and it also has electrical switch in there as well. But it works as a fulcrum, and it locks in place if you move it back and forth. And they come as a kit. I'm going to be showing you more of this here. Let me come back here. It comes as a kit, and you build it up, and so as a result, it's actually made out of I think it's like 2 or 3 mil plywood that he laser cuts and then you glue together. But before I show you more about that, this is kind of the outline of what I'm going to be talking about. Um, Part three, I've got a whole bunch of notes, and really, so you don't have to write a bunch down. It's mostly in there. And what I do is I actually write notes to myself or manuals to myself, and that's basically what this is. Over the years, if you do something, I find that I forget how to do it 6 months later. So I basically write myself a little manual on everything I do. But this is kind of the outline of what we're going to be talking about. Um, I'm going to talk, before we get too far into the bullfrogs, I want to talk about different ways of wiring turnouts as well. So I'm not going to spend all the time just on the bullfrog, but a couple of other things that apply to any way of controlling a turnout. Also, there's um, tons of information. In fact, the manufacturer, Tim, has a number of wonderful videos on his website that kind of shows you how to build these, put them together, etc. So, and I'm not going to cover all that. He does a great job with that. What I'm going to show you is how to install them, and also some of the changes or improvements I think that I've made to the entire system, or just a different take on it. Again, you can buy them in sets of three. Unlike other uh, uh, devices, you got to actually build these, but as a result, they're cheaper, um, and they work really well. I've got about 100 right now installed. And years ago, probably as soon as these came out in like '05 or so, I helped a friend of mine. Unfortunately, he's no longer with us. Dewey Norton. He had bought these just to try them out, and to help him out, I actually took the kits home and built them and brought them back the next week. And we had them in his layout for I think 10 years. And he said, Bill, they never didn't work. They always worked. In fact, they're the most reliable type of system he had. And again, these things switch both mechanically and electrically on the polarity. And again, this is what they look like. It's kind of a quick off their website what it looks like. Again, made out of plywood, and you glue it together. This is some other products they've got where if you've got some tight spaces, you can kind of break it apart into two parts and put it wherever you need to. I haven't needed to do this so far, so that's helped me out quite a bit. Um, this I build my layout in modules, as you can see. I think this is about 4 foot by 18 inches, which is kind of my standard module size. And I don't like, and I've done it before, I don't like working on the floor, reaching up, putting switch machines in. And I've used everything under the sun, including the old twin coil. I spent way too many hours trying to make those work. But here I'm working at a workbench, and in this picture here, this is the actual Bullfrog here that's sitting beneath the turnout, and this is the actuating rod. And I'm going to show you how to build that, and I make this handle as well. We'll show you that. And one of the advantages with the Bullfrog is unlike, say, some of the slow motion type machines and other switch machines, I'm not, other than wiring the frog, there are no wires involved. There's no electrical switches to push. And as a result, it forces your operators to kind of move along with the train as a brakeman or a conductor would, and switching it at that particular location. But again, this is just an overview picture of where we're going to get to. This is what one of the kits looks like. It just comes as a bunch of pieces, and you glue it together, and it looks difficult, but if you do one or two, suddenly you can do them in your sleep. You can listen to music, watch TV, whatever. I probably got 140 of these built, and didn't take that long. But this is what kind of the basic kit looks like, and it gives you all the hardware. It gives you everything you need to make it work, but this is the wood portion of the kit. And the other thing it does, and we're going to review some of this stuff, I know many of you may know this, but with an all-metal turnout, you've got to change the polarity of the frog. Otherwise, you can have a short. So in this instance, and the Bullfrog does this. There's an electrical switch in there that switches as you move the lever, and it can change the polarity for the frog. And in this instance, the frog is right there, and you can change it. And that's real. It's critical. I mean, if you've got kind of a completely isolated frog, you may not need to worry about this. But it does give you this, and I'll show you more about how I actually wire all this later on. Again, this is the basic idea of how frogs are wired. Just gives you an idea. And now with DCC quote unquote friendly turnouts, the closure rail and the stock rail need to really be the same polarity, and you're just going to change the frog. One of the things that I do a little differently, like in this picture, the frog's short. It's maybe 1 or 2 inches long, depending upon the scale and the size of your turnout. But I don't do it that way. I actually use the ends of the rail coming off the frog, and insulate those 2 points. It's not the standard way of doing it, and I'm not saying you should do it, but if you build your own switches, you're able to do this, and it actually cuts down on the number of joints and solder joints you have to have. So this is what I do, but I'll show you more. Again, some of the things, best method, I just wire every rail is soldered to something. I do not rely upon rail joiners. I do not solder wires to rail joiners for a number of different reasons. I use rail joiners just for mechanical purposes, not to conduct electricity. And if you're building it, it's not that hard to drop feeders, and it's really frustrating to go to a layout and there's not enough feeders. So what I do is I just insulate at the end of the switch, and the frog becomes much bigger. And here, I call it the non-traditional way of doing it, there's 6 solder joints, one for the frog and 2 for the 2 stock rails, so to speak. And then they're insulated at the end. The traditional way is to have kind of the frog is separate, and this way you've got more joints or more solder joints to put in. Again, you can do it that way. And if the manufacturer gives it to you this way, well, of course, then you got to do it this way. And again, doing it my way with the non-traditional way, if you got a crossover, it becomes even more. This is the number of joints you got versus this is what you're going to have to do with a crossover. There's more involved, more things to do, more things to mess up, but just something to think over that I've never seen anybody else talk about. Um, and this is like how I basically build my turnouts using the fast track jigs. Is I don't normally people would put the would cut through here and isolate the frog, and that's fine. Um, Particularly if you're sure your engines you can cross this, then maybe you don't even have to power the frog. But I actually insulate it out here instead, and this whole piece then this whole frog piece gets changed. And I like it because I don't put joints here, and by cutting this, it makes this turnout mechanically less stout. It's a little stronger this way, so I try to keep it together, and I isolate just at the end of the where it's indicated. But again, if you got to make your own in order to do that. This is, as I mentioned, this is kind of just an outline of the sequence of installing the bullfrogs and putting turnouts in. And I'll start with making sure the throw rod has a number 56 hole in the center of the throw bar. You need to do that ahead of time because that's going to help you locate the turnout and the hole that you're going to need to put the actuating rod. And again, I'm not going to go through this, but it's here, so you can come back and look at this and make copies of it as you want. Um, the key too is that you can't put the turnout in and make it permanent, like glue the turnout in, and then try to drill a hole to actuate it. You got to put the turnout down, take it off, drill the hole, then put it back, and then install the bullfrog from below. And again, these are the procedures. And I use a 1/4 inch hole below the throw bar. We'll cover all that. Again, these are just the procedures you need to go through one by one by one. These are my own notes. And I use number 18 wire to wire everything up. I'll show you that as well. The fast track itself, this is kind of their standard way of controlling the bullfrog. At the end of the bullfrog, they give you this. This is part of the kit, and you attach that to these RC cables, and they have kind of a knob. I just don't like the feel of it. My friend again Dewey had that, and I just didn't like the feel. They work though. There's nothing wrong with it, and they sell you all the parts, or you can go to an RC store and get the cables. They're not that expensive. And the advantage is you can bend them. You can, in fact, we had it where you were controlled it at 180 degree. It made a whole half curve. Come back and switch it. So this is a standard way of doing it. So we're going to start locating. How to get the turnout. The first step is locating the turnout on the layout. And what I do is I have a design. I have like basically a blueprint, a computer design of all the turnouts. So before the turnouts are the first thing that go in, and I cluster them. If there's 2 or 3 turnouts together, that's where I start, and I draw lines on the track board, however you want to do it. So the first kind of step is locating the turnout on the layout, and you can see there's kind of crosshairs. I'll give you some more pictures here. Yeah, and this shows, here's the center line going through here. And then what I'm going to do is I'm going to mark here and here. So I know exactly where the middle of the throw rod is, because that's where we're going to drill our hole. And I gently spike this down, maybe a couple of spikes just to hold it in place. And then I'll drill down through the center of that throw rod. That's why having that hole there is important to get that done beforehand. And then use a slightly smaller drill to mark the hole in the track board. So again, there's just a couple of spikes there that are holding it there temporarily. And again, you can see that it's right on the center line. Uh, Boom. And I try to put the hole in the middle of the track. So I've got the closure rails, or the point rails centered between the closure rails here. And I'm just going to drill a hole through there, mark it like right there. That's a very, very good close up. And I do that in order to make sure that the location of the hole that goes below is perfect. This is really critical. If you do this, I have not had to redo anything, where in the past I was always redoing things. So if you mark it perfectly, it's going to make life easier for you later on. So once I've got it marked, I'm going to come through and use a 1/4 inch drill bit and drill the clearance hole below where the throw rod was. And I'm not just going to drill it haphazardly and just hope it's right. As you can see, um, there's uh, a dowel jig that I use. They're relatively inexpensive. This is a cheap one, and that's all I need. And I just have it set up for a 1/4 inch drill to make sure that it's going down straight and square. And if you do that, it's going to help you later on. It's not a bunch of extra work. And eventually, what's going to happen is once the Bullfrog's installed, it's going to come up from below, and we'll cut this throw rod off later. But this is really what we're trying to get to, and we'll come back to that. And as you can see, I've got the turnout marked, so I can put it right back to where it wanted to go. And this is what I'm using. It's just a standard 1/4 inch uh, wood drill, and I like the type with the center brad point, because then I can put it right where it needs to be, and I use that doweling jig to get that hole perfect. And again, here's the doweling jig set right on top, and I'm using my drill and just drilling down. And that way, it's going to be absolutely straight. You're not going to get any misadjustment. And it's amazing. If you go out down a little bit and it's off, you're going to be struggling with it later. And I've been over to many houses trying to fix other people's messes. This prevents it. Again, these are cheap. Anything that and you don't even need to buy this. There's other ways of making sure that you're drilling straight and true. It's critical. And again, this is what you end up with: just a 1/4 inch hole right in the center of the crosshairs. I guess it could be different dimension, but my track board is 1 inch thick, and 1/4 inch is all you need. And what I'm not doing is I'm not gouging it out and making a groove. Other people would do that, and I'm going to show you why it's a number one. You don't need to do it. It just makes a mess, and if you make a mistake, it's harder to fix. And we'll cover that at the end. And again, once the hole is drilled, I put the turnout back in over where it was, and I'll spike it in place. I do not glue track anywhere. I don't like glue really anywhere. I like to be able to move things and reuse things. And track and turnouts are expensive and hard to build. And if I may want to use this somewhere else, so I do not glue track down. If you want to keep Atlas in business, I guess that's a great idea. I don't. So anyway, this thing gets spiked back in place. Right there, you can see some of the spikes I use, and you don't even need that many just to hold it in place. And then once it's in, it's spiked down, ready to go. And the turnouts are the critical part. Everything else gets easier afterwards. Eventually, this is kind of out of place, but this is the controller I use on top of piano wire, and it's a ball that I create for the handle, which replaces the one that Fast Track gives you. But we'll come back to that. I just wanted to show you where we're going with this. The next part, and this is the critical part, is locating the screws to attach the Bullfrog. And so after the hole is drilled, you can flip over the module, or you may have to go below it if the layout's already in place. And I create this little jig here, and all it is it's 80 mil styrene, and this is a 1/4 inch, same as the hole we just drilled, that goes in through the hole here. And it's based off of a paper jig that you get from Fast Track. It may be in every kit they give you, but it's on their documentation. And I just turned the paper template into this beat up piece of styrene, as you can see. And I've also got holes here so that I can locate it on either side. Um, yeah, and here's the other side of it. And that little piece of that 1/4 inch goes into the hole we just drilled. And and then I line up where the center line is going to be, and then I just drill those holes out because those are the holes that are going to hold the screws that hold the Bullfrog in place. In this part, it seems like I'm going through a lot of detail here, but if you do this and you do it repetitively, it's always going to line up. You'll never have to make adjustments. And again, part of it is the great design of this Bullfrog and the material they're using for that piano wire. There's something about the wire that they use that's very springy. It gives it, but it's not too tight. And in fact, when I bought these, I get extra piano wire. It's a different alloy. I don't know what it is, and it works better than anything I've ever seen. And they'll sell you extra, and it's not that much more money, and it's worth it if you end up cutting one too short. Anyway, this is a critical part. We got the holes drilled, so we're ready to install the Bullfrog. And as you can see, I give a rough idea of above where the center line is, so I can align it up. It doesn't even have to be perfect, just close enough. And now because of the way I'm doing it, I can see the throw rod through that access hole, like right there. And it's through that I'm going to want to put the actuating wire through that little hole there in the throw rod that's in that hole there. So that's kind of where we're going with this. Again, another picture of that. You can see where I'm going, and I put the light on the other side. I suppose you could do it from above, so that way it's real easy to put the throw rod through. It's very easy to find, and once it's in, man, it just lines up real quick. I install these with these screws. I don't just use any screws. Whatever you use, if you don't want to use these, that's fine. My recommendation is use the same screw, use the same heads type. Like these you can't see it, but it's a Robertson, number 2 Robertson. Um, and this is all I use for all of my turnout controls. And the reason is, um, if I have to go underneath and adjust something, I only have to take one tool. I don't have to guess. Is this a Phillips head? Is this a slot? Is this whatever? I know it's a number 2 Robertson, and to me, that's the best type screw. And it's just number 6. You can see it's made for wood with the large threads. So anyway, before I install it, again, this is a little trick I came up with. I, in a sense, sharpen the end of that actuating rod with a grinder. It just makes it easier to find the throw rod above, and I take any burrs off, and it kind of makes it a little smaller, makes it easier. The other thing I do is in here. This goes back and forth on this actuating, and what this is I just use some. You need some wax here, and what I did is I just bought some really inexpensive uh, kids crayons and just use that, and it kind of lubricates it. The wax kind of makes it a little easier for those wood parts to go back and to rock back and forth on. Just a little trick. So here I am, ready to install it. Here's the Bullfrog. It's been built, obviously. The other thing notice, and we'll come back, is all 3 wires are soldered to the switch. That's critical. I'm not doing this later. Let's do that. It's so much easier to wire it at your workbench and rather than doing it underneath the layout. And at this point, I've put it through the throw rod above, and it's just hanging there. And I'm just ready to install it. And the other thing too is notice where this access hole is. That's got to always point towards the front where the control rod's going to go. So it's going to flip around in this picture, like right there. And now I just go in there with a screwdriver and just screw it in place. I've never even had to adjust these ever. They just line up. There's enough overage here. It just works perfectly, which is just a huge advantage over anything else I've done. Again, another picture. Wires are already soldered. I'm not doing it now. I've done it before. Kind of more of a picture there. And again, sometimes I'll put some tape over on the top side to hold the throw rod in the center. And going back here, notice how when I'm installing it, I want this in the center. It makes it easier. And I try to keep the throw rod centered above as well. And that's what the tape was doing there. So right there. So everything's centered, and then you can take the tape off and make it work. And this is what we're going to get to, where it's going to come up through above from and it's going to flip back and forth. And eventually we're going to come back with the grinder and take off the excess piano wire, obviously, but that's easy to do later on. So the next step is making the actuator rods. And this is eventually what you see is the knob with the rods, and this replaces the RC. What I use is 440 piano wire, and you can buy it threaded at one end, and you got the website there. This is where I go to get it. I think you can buy it in 12-inch and 30-inch lengths. And when you buy it though, the threads are on one end, which is fine. You're going to have to put threads at the other end because both sides have to be threaded. But that's not going to be a big problem, and I'm going to show you how we deal with that. So that's the stock material. You could try 2-56, which is less stout. Suggest you try both, see what works for you. In order to hook these, to get the control rods connected to the bottom of the pivot on the Bullfrog, this is the device I use. It's an RC part that they use, obviously, in RC planes and cars to actuate control surfaces from their relays and little electric motors, etc. And I just buy these and then hook these to the Bullfrogs. And then this piece here is threaded, and so the throw rod will get threaded through there, as we'll see. But that's where we're going with this. And this is where it's all set up. So this is the end result. We're going to show you a little bit more where we're going. But it gets threaded into that clevis and then threaded up above to hold the knob. Yeah, here's some better pictures where that metal clevis is hooked into the bottom of the Bullfrog. On some of these, I actually just carved this out because I don't really need this to hold the RC. This gives more clearance. And that's the 440 piano wire coming out. Again, some more pictures. There's a really good picture of that clevis, and it just you open it up and clip it into one of the holes here on the base of the Bullfrog, and you just thread this in, and it's not going anywhere. Again, if it'll work in an airplane flying 100 feet up in the air, I'm it'll work here great. Get some more pictures. Sometimes if the alignment isn't perfectly straight, you can still use some of the control rod material and hook that up to the Bullfrog, and then later on hook it up to the throw rod. You can kind of combine some of these products if you've got an area where it's got to loop around or bypass something. So you're not stuck just doing one thing. I'm just showing you a couple of alternatives. Now, once you get the rod put through, into the Bullfrog, you drill a hole in the front edge, and obviously the wire is longer than what you're going to need, which is fine. But you drill that hole, and everything's always consistent. It's like 2 inches off the base for what I'm doing. And then you got to figure out how much room you push it in, figure out how much room you need, and then you cut it off. And you can't. I mean, you could use your Dremel tool, I suppose, but I'm doing enough of these that you need a specialized, in my mind, a really heavy duty, high quality, in a sense, a metal cutter. And this is the one that I use here. It's been really effective. It's not inexpensive, but it's made to cut, as you can see, piano wire, and it's really effective. And I don't use it for anything else. It stays just for this purpose here. And then here's the rod here. The other thing, I don't do any of the wiring until after the Bullfrogs are in. because I don't want any of these bus wires in the way. I just mentioned that because you can see the bus wires here. And there it is, a little, little more explanation of what it looks like with the clevis. And this is ready to go in. You thread it through, hold it in place, not a big deal. And this is where you have a tight configuration where you got to do some fancy work, some adjustments. Now, before I was showing you, we had the end. We've got to put threads on the end of this piano wire. So I took it off the bench, put it in my vise, and then we got to put threads on that end. So in order to do it, you need a sense of die that's going to carve in the threads. And these are not that expensive. I think I bought this on Amazon for not a lot of money. You got to buy the handle, which in this case was an M25, I think 1 inch. And then this is the die in a sense that you buy. And this one is set for 440. And there's some videos out there that'll show you how to do this, but it's really not that hard. The most difficult part is making sure that the die is square to the rod. So you make sure the rod is in there, straight and perpendicular. And then you just work it down and carve the threads on. But watch a couple of videos on that. It's not that difficult. And this tool isn't all that much money anyway. In a sense, it's the reverse of tapping something where you're putting threads inside. Here, you're putting the threads on the outside. That's essentially what you're doing. And it's not that hard. Just you go down, carve it out, just like tapping, carve back out to get the shavings out. So once you've got the piano wire in, we got to make the control knob. So what I do is I push the rod in to its furthest point, and then I take this control knob, and I'll tell you about how to build that in a second, and figure out where I need to cut the piano wire. So that you need one of those to when you're doing the above step, which is cutting the piano wire. So again, here it's been cut off. Then I'll take it out. Then I'll put it into the vise and put the threads on, and then I'll put it back in and then put the knob on. In order to let me go back and forth. The control thing is this is just a 3/4 inch wooden ball. I think it's made out of oak. I bought it at Hobby Lobby. I think 50 at a time. They're not that expensive. But the hard part is you got to figure out how to drill a hole into it in order to thread it onto the piano wire. And this is something I found. You drill out a hole and it's like a block of wood, a little bit smaller than the total diameter. Maybe that's a 1/2 inch hole, and right there. And then they put it on a small drill press, and just drill it slightly smaller than the piano wire. And I think I thread those out too. I tap those too. It's really simple to do. And I make over 100 of these, maybe 150 of these at a time. It's like if you're going to do them quick. And as you can see, I've also spray painted them. I got some Rust-Oleum, just painted them all, took them outside, spray painted everything so I don't have to come back and do it. But this is a quick way of making these control handles, if you will. You can use anything. I just like these. They're just simple balls made of 3/4 inch balls, just something to hold on to like a handle. So next step is once you got the mechanical part, we got it all hooked up. What do we do? After it's in, then I'll put the bus wires in. As you can see, everything's color coded. The bus is red and black, and then you wire the frog. And the way I do it, as you saw earlier, when I wire the switch on the frog, the frog wire, I just use green wire. I don't use anything but green wire because frogs are green, and you can't forget that. And I use 18 gauge solid for all of this. I don't use stranded. There's no stranded there's just no reason to use it. I use solid 18, which is plenty. And then the other two that go to the bus wires, you can use whatever, I suppose. I just happen to have black and white, same thing, 18 solid. But notice that the black doesn't necessarily go to the black wire because it depends how the turnout is aligned and what the frog polarity is going to be. And you have to check that later. But this is the basic outline. I'm going to, the frog goes to the frog, and then I figure out which side has to be hot. And some of it is just you got to look at it, you got to test it. Um, and as you can see here, the white wire goes to the black, so it really depends. And the other thing here in this example is here's the frog wire coming from the bullfrog. Here it is coming down from above from the frog, the lead, and then I just use a suitcase connector, what they call a suitcase connector, to put the two together. And again, when you're down below, just put the two greens together and make sure it's the correct turnout. So if you get 3 or 4 turnouts, and I've done it, make sure you're hooking up the frog wire from the bullfrog to the correct frog. Again, I've messed that up. And in order to figure out what the polarity is, you can either look at it, kind of look above and go, okay, the black wire is hot, which one it is, and then hook that up, or use a continuity tester to figure out what's hot and what the frog should be in the way the points are aligned. It's kind of you got to keep looking at it and checking it out. The other thing I do is I put one switch in and check it and make sure it's not shorting. I don't want to put 5 switches in and then come back and try to find a short. It's much, much harder. Check each turnout before moving on. And again, here's the completed module with all the wiring. A couple other things I wanted to cover here. I want to talk about some track joiners and ground throws. It's a little above and beyond, but it's still dealing with track. And what I do for my rail joiners, number one, this is not a great example. I now have staggered the joints like 2 or 3 inches apart, so it doesn't look like I'm using some sort of sectional track, even though I'm using 3-foot lengths of flex track. And I actually I make my own fish plates out of styrene and glue these in. And believe it or not, it actually holds the rail quite well, other than on curves. If it's tangent track, it works real well. On curve track, you have to do some other things. You may need rail joiners, but I like to stagger joints. That's the number one thing. If you can do it, it looks too much like a model railroad. And this is an example where just using this as an example, this is just 2 turnouts that I built, and then it's just microengineering flex track that I intersperse in there. And I pre-paint everything, and I make it so it's very difficult to figure out where the turnout begins and where does it end and where does the flex track begin. I want it to kind of flow together. So a lot of times the joints aren't next to each other. So in this example here, I think the rail ends here and then it's back here. So when the next piece comes in, you really can't tell where they come together. They're kind of spliced together. And I just think it looks better, and it takes a little more effort, not much, but to me it kind of makes it worthwhile. And depending on your scale, I just use little strips of styrene, cut them up into lengths. If you want to get crazy, 3 foot is the standard on mainline, 2 foot, but your eye won't really know. And I just make it out of that and then pre-paint it too. A lot of times it's just easier to pre-paint it. And just use some super glue and glue it in place. Just a different idea. I've tried buying the nut bolt washers in an HO. I can't see it. I tried it and I was like, this is not worth it. The other thing too, again, this is, and I've used these are great. But one of the things with the bullfrogs I like to do, or what I try to do, if at all possible, is I try not to have the turnout controls on the layout surface. I want them below. Number one, using these are they work real well. But when you start photographing your layout, boy, these don't look very good. And when you're operating, it's one more thing where you have to, or your operators have to, reach up to throw a turnout. And it's just one more chance they have of touching the layout, hitting something. Where if the controls are below, it's just easier, particularly if your hands um, are busy, with a pencil or car cards, whatever. So I'm trying to replace that. That was what Bullfrog does. What it also does is it forces you to um, the operators, whether the brakeman, conductor, however you set your situation up, they have to walk to the turnout to throw it, which is in reality what they always did. There aren't a bunch of little electronic switches being pushed. Also, with the Bullfrogs, you can put any kind of um, call it scale switch machines in place, like we've got here. You can do whatever you want so it fits your scale, fits your period, and the prototype may have different switch stands, and you're able to do that much more readily than if you've got something that's up on top. And this is kind of the reasons why it's just nice to avoid using some of the ground uh, surface controllers. Again, they're useful, they work, I get it. I've been there. It's just giving you some other ideas. I'm not saying it's wrong, it's just that there's some different ways of doing it. Some other thoughts about controlling turnouts is figure out where the gaps have to go, where the insulation has to go. I've seen this so many times. I've been in layouts, and somebody just came in with a big Dremel and just went zzz, and then they never fixed it. It's just this big gaping hole, and the ballast is everywhere, and it's just a mess. And it's just one of those things is if you think ahead of time where the gaps have to go and you build those in, you don't have to come back and do this and just make a mess. Um, and so I try to avoid this whenever possible. And actually, for my insulation, I just use little pieces of styrene that I glue between the rail and then carve them down with an X-Acto and a little file and then paint them, and they just completely disappear. You can't, you really can't tell where the insulation is. Don't use insulated rail joiners anymore for that reason. Same thing. I'm trying to avoid stuff like this. It's kind of ugly. So try to come up with different ideas. The other thing too that everybody does is they'll put the joints together like this, and then they don't backfill in with ties, and you can tell it's just a model railroad, and you can see where the sectional track ends. I just try to avoid this. I've done it, been there, done it. I just try to avoid it. Same thing here. Trying to avoid these kind of issues. Again, a couple of last things. Just want to finish up. Um, I've mentioned about using the quarter-inch hole. One of the reasons for doing this, and I know I think on one of Tim Ware's um, videos, he actually goes in and it almost like routes out like a groove, and you can do it, but it makes an absolute mess. Where if you just drill this quarter-inch hole, one of the advantages is it's real easy to fix because it's a standard size. Again, if it was millimeters, you could do the same thing. But because it's a standard size, like right here, this I drilled this in the wrong place, or I decided to move the turnout to the left a little bit. So I had this hole. I could have covered it up with track, but just use this as an example. I just get a quarter-inch piece of dowel. It's like 1 inch long, whatever, and just with a little hammer, just go pop, 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 put it in. You can cover it up with some paint if you want to, but suddenly it just disappears, and you're right back to where you need to be. Also, if you're going to ballast, the ballast isn't going to go down that hole either. It's just boom. But again, if you gouge it out, then you got a mess. Then you got to use spackle. It's like, no, I don't want to deal with any of that. Just to my last thoughts here then too is in this picture, this is the back side. And as you can see here, this is where the feeders come up. And what I want to do is I make sure that they're on the back side. I don't do them on the front side. And then I use soldering flux with acid, and I like to clean those up with the alcohol. So if you use flux, that's fine in my mind, but clean them up because if you don't, the solder will continue to work on that joint, eventually break it. Again, how do I know? Because I've been there. Then once it's cleaned up, the last thing I do, I like to come in and just touch it up with some the paint I use in all of my track. And I mix up my own railroad tie brown. I use Tamiya paint, but you could use anything you want. That's kind of where we're at with all of this. So that's it. And any questions out there? I'm turning it back to you, Mr. Speed.
Of course, there's questions. Of course, we have to start at the beginning, right? So when you talked about adding the wires to the turnout, someone asked, do you add feeders to your points as well?
No, and that's a great question. I'm wondering. Let me go back. Let me see. Let me find a picture. Find a picture of a turnout. I'm getting close. Hold on. I'm sorry. I have a picture. It's going to be easier to explain it. Okay. Happens here. This isn't a great picture, but when I build my own, and it depends on the type of turnout, but when I build these with fast track, some of these are copper clad ties. So when I'm building them, these two get connected anyway. So for the turnout, the only uh, drops I have are the stock rail. The point rails will get fed from there directly. So I don't have to individually do the point rails because there's a copper clad tie in there that's connecting those two together. And these are quote unquote DC friendly. So the point rail and the closure rail or stock rail is the same polarity. So the short answer is no, but it depends on the manufacturer. If you had the old Shinichara, then you would have to do something like that.
So you're saying the points are soldered there.
Yeah, and so right in here, somewhere in here, like this is like a, it's not a perfect picture, but this would be like a copper clad tie. And so this is soldered here, and that's soldered here. And then there's a gap here. And then this is soldered to that. So when I drop a feeder from the stock rail, that point rail is automatically powered. And that's critical, and so at the end of the day, every rail has a feeder somewhere. I'm not relying upon some sort of rail joiner at all. Somehow there's a solder joint somewhere.
Cool. We had to do some math for the people who like millimeters, but I want to know, how did you pick a number 54 drill and not a number 55 or a number 53?
Yeah, I'm trying. What I did was the reason I did it is on these. Uh, this is the throw rod. The throw rod, I guess, is what we'll call it. That comes with the bullfrogs. And so I took my calipers out, and you could do it in imperial. And I love metric too. I've tried to move over to metric, but everything I can do here is I still do thousands of inches. It works. Um, and basically, I just mic'd out that wire and figured out that the 56 was just slightly bigger. And you don't want it too tight. And they may even have instructions in there, but the 56 drill bit is enough clearance where there's just a little bit of wiggle with the wire that comes with the bullfrogs. So, and again, I fooled around with this. It wasn't just a random. I tried 3 or 4 different things at some point, and this is the one that came out best because you don't want it totally tight, but you don't want it real sloppy either.
Okay. Since you mentioned the frog juicers, do you use circuit breakers on your layout?
Um, Circuit breakers, no. And I don't use the frog juicer. I'm using just that little electric switch to throw
Correct.
the polarity. Again, frog juicer, there's nothing wrong with them, but this is like free. I mean, it's cheap. And so I just use the mechanical switch, and it works every time. I haven't had any trouble. And my friend Dewey, same thing. We used this thing for over a decade, never had trouble. You could use a frog juicer instead if you want, or if you have a little short frog that's only an inch long, and your engines can go over it, then you don't really even have to power the frog if you got the right kind of locomotives. I just am very conservative, and I don't know what's going to run, and I just power everything.
Okay.
Um,
But if you short the track out there, the booster will cut it
yeah,
off, or do you put
yeah.
a circuit breaker in parts
No,
of your layout?
what I've done, I've broken my layout up into I think it's 7 or 8 different power zones. I use CVP, and so generally there's only going to be one locomotive in that district, if you will. So, and it's everything else is totally isolated. So if somebody runs the turnout, which is really normally that's about the only way it's going to short out. Somebody gets silly, me, and runs the turnout. It's going to beep, shut down until I throw the turnout. I don't add a special circuit breaker, and I've done it. It doesn't break anything. As soon as I throw the switch to the correct location, everything comes back on. But again, I put I think 7 or 8 different power zones in the layout itself, and it's only really running one engine at a time.
So at some point you said you take the excess piano wire off. Is there
Yeah,
a reason for that?
yeah, because like in this example here, when I after this is like where I've installed the Bullfrog from below. So I've always got this excess piano wire. I don't want it too short. I want it to come up long. Then once it's in place, then I'll come back with the grinding wheel and get this closer so that it doesn't interfere with the cars and the engine and so forth. But I like it long so that it'll I can locate it and then I'll come back and clean this up.
Okay.
That's what
So
I was talking about.
there's no piano wire sticking down the bottom.
No, no, it's coming up from the Bullfrog. This is the actuator rod from the Bullfrog, and, but I do sharpen that edge. I would have sharpened that edge with my Dremel just to make it easier to thread through the hole in the throw bar.
Okay. Next question is when you thread that rod, how do
Yeah.
you know how long to thread it?
What I do is I thread it about, at least 3/4 inch, about 3/4 inch or a little less because now, in my case, the ball itself is 3/4 inch. So the amount that has to be threaded, the hole isn't going through the entire ball. It's maybe 3/4 of the way. So if I thread it 3/4 of an inch or a little over half inch, 5/8, that's plenty. If you had a big ball that's an inch or inch and a half, then you might do more.
Cool. Here's an awesome question. How do you reverse the bullfrog? So when the rod is pushed in, then it's aligned for the main line. But if you need to push it in and it goes the opposite direction, is there a way to reverse them?
That's a great question. Only a crazy model railroad would ask that question, but no, that's actually come up. The way it again, I mentioned my friend Dewey Norton. I still miss him to this day. Great friend. What he did, this is one of the things he did, was he wanted all of the buttons in, if you call them the handles buttons, in if it was a mainline turnout, meaning when he
Yes.
left, everything needed to be so 50% of the time, on average, it's going to be in the right position. On average, 50% it won't. So what he did, I would not do this, but what he did, and I helped him, was he took the cable and he ran it 180 degrees. So the actuating rod came from the back side, so it can
Okay.
reverse it. So there are ways of doing it. I just don't find it's not worth it for me. But he did it because when he left, he wanted everything pushed in and know that all the turnouts are normalized. So, and that's how you do it with the control rods.
Cool. Last question. You showed some switch stands there without the manual throws on top. Do you have those animated so that they would rotate and show different
Uh,
colors?
Um, I don't. I've actually built, I think, over 100. I don't have a picture of them here with the and my prototype has like a little lantern, and I've got the little tiny jewels that sit in there, but I don't have it actuated. But I've drooled over, and I can't remember. He's a wonderful guy. I've met him from Canada. He had an S scale layout, and he had done that. I can't remember his name, and I haven't done it. I got too many turnouts, but I would love to do it. If I had an O scale layout with about 12 turnouts, I would do that. But it's hard to do in HO.
Well, Bill, that came bring us to the end of the questions and the end of the show. Thank you very, very much. Um, I might ask that you repeat this whole thing for N scale so we can get those tie plates in there as well.
Okay,
Follow.
let me get my optivisors on.
Thank you very, very much.
Thanks, Speed. Thank you very much. Bye bye.